manufacturers of products often use standard deviation, mean, and z-scores to determine what kind of warranty they offer on their product. They know that eventually the product will fail. Most of the products will fail as a normal distribution, so very few will fail early, very few will fail late, but most will fail in the middle. So this manufacturer, in their testing, they know that the mean life of this music player that they're making is 32.4 months, standard deviation 6.3 months. They want to determine what kind of warranty should be offered if they want to replace or repair less than 1.5%. Well, we know mean. We know standard deviation. 1.5% tells us Z indirectly. So we need to go back to our z-score table, and we need to find 1.5%. Being careful to remember that 0.0015 is not 1.5%. 0.15, which would be between those two, is not 1.5%. 1.5% is 0.015. Now we're in luck because that shows up exactly in the z-score table. If it didn't, we'd have to guesstimate between two values, doing our best guess as we could. So what z-score does that correspond to? Well, it'll start with negative 2.1 and it'll be negative 2.17. So we go to the formula. We fill in what we know. We know Z. We don't know X because that's going to be the length of the warranty. Mean is 32.4. Standard deviation 6.3. First step, we'll multiply both sides by 6.3. Cancels that. Negative 13.671 is what we get on the left. Add 32.4 to both sides. Cancels that. And we get that X equals 18.729, and that would be months. Now, no company in the world would actually advertise a warranty as 18.729 months. They likely wouldn't even say 18.7 months. So now the question is, do they advertise as 18 months or 19 months? Well, if you think about it, 19 months, you would have a few more players fail in those 0.3 months. And if they don't want to replace any more than 1.5%, that might push them to 1.6% if they wait till 19 months. So they would likely say 18 months and possibly only have to replace 1.4%.